for example 1b, and this is again 8e, factor completely. So I'm going to put 8e, and this is video 2. We're going to take a look. So again, we're going to think standard form. So x to the fourth, x to the second, no x's, check. Is there a GCF? There's an x, no x, so no GCF. Count the terms, 1, 2, 3. Because I have 3 terms, I'm going to do the AC method. So my A is 1, my C is 16. So for this, AC is a positive 16. So we're going to have a 1 and a 16, a 2 and an 8, and a 4 and a 4. Here's one that adds up to positive 17, but I need a negative. So that means this will be a negative and a negative. So remember, you need to be careful with the signs to make sure not only do they add to negative 17, but they still multiply to be positive 16, which it does. So I'm going to choose these two numbers. So I will have x to the fourth minus 1x squared minus 16x squared. So that gives me my minus 17x squared plus 16. Then I'm going to, now I have 4 terms, so I'm going to group 2. GCF here is x to the second, and that leaves me with x to the second minus 1. My third term is a minus, so I'm going to put a minus in the middle here, and I see that 16 will go into both those terms. That's going to leave me with x squared, and then 16 divided by negative 16 is negative 1. So once I've finished, I see that my parentheses are indeed the same, which they must be. And because they are, I'll factor them out, get x squared minus 1, and be left with x squared minus 16. And I factored. So it is in factored form because it's a multiplication problem. This parentheses times that parentheses. However, is it completely factored? So again, remember, we need to look at each parentheses and determine, is it still the difference? Yes. Of squares? Yes. So this is the difference of squares and must be factored again. So we'll factor it into x and x, a plus and a minus, in 1 times 1. All right, so now go to my next parentheses. Is it the difference of squares? And the answer is yes, it is. So it too will factor into a product of 2 parentheses. So that'll be an x and an x, a plus and a minus. And for the 16, that's going to be 4 and 4. Again, look, you see we still have some differences, but is this a square? No, it is not, so I stop. Same thing here. Here's a difference. 4 is a square, but x is not a square, so this is not the difference of squares because of that. And this is my answer. All right, so let me look at one more here. So for this next one, I will first say, is it in standard form? 4, 3, 2, 1. Answer is yes, it is. So the next question, does it have a GCF? Well, I see these are all even, so yes, there. So, and I see that they all have x's. So it looks like I could factor out the GCF of 2 and an x. And that's going to leave me with then 2x to the fourth over 2x is x to the third plus 3x to the second minus 8x squared over 2x. That's going to be 4x minus 24x divided by 2x is 12. All right, so I'm going to just take a quick look. It looks like that's factored. There are no numbers or variables, so I'll continue to go in that. All right, so now I'm going to count the terms. 1, 2, 3, 4. I see 4 terms, so I'm going to group 2, group 2. This 2x is going to stay in front. I'm going to kind of like just do this kind of on its own. So I'm going to have x squared times x plus 3 minus 4. and that's going to be x, and negative over negative is positive 3. And when I look then at this, I see my parentheses are the same, and so I'm going to factor out the x plus 3, and I'm left with x squared minus 4. All right, so now I factored it. Everything is a product, this times parentheses times this. So the next question is one of my factors the difference of squares? And the answer is yes, right here. So I see that's the difference of squares. So I'm going to have 2x, x plus 3. I'm going to factor this into x and x plus and minus 2 and 2. And I don't see any more squares that I can factor. So this is my answer.